Welcome back. Today we will be solving some problems related to electrostatic. Okay, in this video. So our first problem, a very basic problem. You all can do this. That is, how many electrons are there in 1 coulomb of negative charge? Okay. As you know that excess of electron causes a charge to be negative, and I have told you in the I think first video or second video I think that one electron contains a charge 1.6 into 10 power minus 19 coulomb, that too in negative. Okay, so uh, the question has asked us to calculate the number of electrons in 1 coulomb of charge. Okay, this is mine in 1 coulomb. Okay, so just we need to divide n by n equals to uh, q upon e. Okay, q upon charge on 1 coulomb. Okay, that is 1.6 into 10 power minus 19. Okay, this implies minus 1 upon minus 1.6 into 10 power minus 19. This goes out, and I think this value comes out to be 6.25 into 10 to the power 6.25 into 10 की power 80. Okay, these are number of electrons. Okay, next problem. Three charges Q1, Q2, Q3 are placed on the vertices of an equilateral triangle of side 1 meter, right? So you have your equilateral triangle like this, right? And side length is 1 meter. Okay, and charges are placed here. Q1 here, let's say Q1 is placed 1 microcoulomb. Okay, here Q2 is placed minus 2 microcoulomb, and here Q3 is placed 3 microcoulomb, right? So the question has asked us to calculate the net electric force on charge Q1. So just look at this. Okay, these uh, 1 microcoulomb and 3 microcoulomb, they are what? They are like charges. Okay, what will the nature of force here? It will be attractive or repulsive? It will be repulsive. Okay, so the force applied by uh, this Q2, it will be in this direction. Okay, due to 3 microcoulomb. Okay, and the force applied by this charge minus 2 microcoulomb to 1, it will be in this direction, right? You can call it F2, you can call it F1, right? So uh, let's calculate F1 and F2. So F1 will be what? It will be 1 upon 4 pi epsilon naught Q1 Q3 over R square. This will be in this direction. Okay, and what will be F2? F2 will be 1 upon 4 pi epsilon naught Q1 Q2 over R square. Okay, so if we put the values here, it will be 9 into 10 power 9 into uh, this is 1 microcoulomb, so into 10 power minus 6 into Q3 is what? 3 microcoulomb over 1 pi square. Okay, so and similarly we can find F2 as well. So right, so F2 will be 9 into 10 power 9 into 10 power minus 6 into 2 into 10 power minus over 1 pi square. So from here you can get the value of F1. Okay, F1 will be your comes out to be I think 2.7 into 10 power minus. You can do it. I'm actually writing the calculator data. Okay, and F2 will be what? It will be 1.8 into 10 की power minus 2. Okay, now you have two vectors. Okay, right? This is vector F1 and this is F2, okay? And you want to calculate the net force on Q1, like on this side, okay? What will be the net force? It will be in this direction, right? And what will be this angle? If this angle is 60 degrees, since they are equilateral triangle, then this angle will be what? It will be 120 degree. So the angle between vector F1 and F2 is 120 degree. You just need to write the vector equation. F net will be what? It will be F1 square plus F2 square plus 2 F1 F2 cos theta. Okay, so it will be, you can do the calculations. You can here you will square the f1 square, then f2 square, then plus 2 f1 f2 cos theta. Here cos theta is what? Cos theta will be cos 120 degree. That means it will be minus 1 by 2. So when you put all these values, then f net comes out to be 2.38 into 10 की power, wait, 2.38 into 10 की power minus 2. Okay, this will be the net force on the charge Q. Okay. So these are the basic. You can also calculate the net force, direction of net force with this line or with this line. Okay, by using this formula, tan alpha is equals to f2 sine theta upon f1 plus f2 cos. Okay, like this. You can calculate this angle. Okay. So these are the basic questions. Okay. One more problem I would like to tell you. Just a second. Uh, the problem is equilibrium of a suspended point charge. Okay, this is actually a quite interesting one. Let me tell you here. I'll just tell you the concept. Okay, here, uh, let's say this is a string. Okay, where two charges are kept like this. Okay, they are actually like charges. Okay, so on a string, so what will happen? Two string is taught here. What will happen? After some time, they will repel each other. Okay, the first charge will be here, and the second will be here, like this. Okay, and the string length is L. Okay, so we need to calculate this distance, right? Right? What will be the distance between the two charges? Okay, suspended point charges. This is quite easy one. You just need to apply the concepts. Okay, this is string. Suppose here tension is T. Okay, and this angle is theta from the vertical. Then this angle will be what? It will also be theta, right? So the vertical component will be what? It will be T cos theta. Okay, and the horizontal component will be T sin theta. And if they are like charges, there will be a F electric. Okay, and here there will be mg, since they also have mass. Okay, so vertical component will balance what? Mg, and the horizontal component will balance electric force, that is k into q square over x square, right? They have charge, they are carrying charge q, and distance between them is x. So these are two equations. You just need to divide it. Okay, just a second. Now dividing 2 by 1, right? So what you'll get? You'll get tan theta is equals to k q square over mg x square. Okay. Now if you look in this triangle, if theta is very small, okay, if theta is very small, right, then what will be the value of? Then value of sine theta will approximately equal to tan theta. You already know this. Okay. So and from this triangle, what will be sine theta? Sine theta is x by 2 over L. This length is what? X by 2, and this length is L, right? So and this is approximately equals to tan theta. So from here, what you write? You will write x by 2L is equal to k q square over mg x square. So x cube equals to 2kl q square over mg, right? So x will be what? It will be, you can say, L q square over 2 pi epsilon naught mg power 1 by 3, right? So this will be the distance between both suspended points. Okay, thank you.